Okay, hello, welcome to my channel. My name is Solo Anch, and in this video we're going to deal with some applications of unit vectors in solving problems on vectors. Good. So this is one of the videos on our series devoted to vectors. And so if it's the first time watching, you may have to go back to the first video on the series that is on the playlist in order to be able to catch up with us. And if it's the first time watching a video on my channel, please don't forget to subscribe to my channel, of course, when you find this video helpful. All right, okay, great. Let's just get right into it. So we want to find vector w, okay, whose length is 12 in the opposite direction of vector v, and vector v is given as that. Okay, so what can we do? Well, in the previous video where we introduced unit vectors, we defined a unit vector to be like this. So if this is a unit vector, this is the notation for that. And then this vector is pointing in the direction of a given vector u. This is how we can write it. So the name unit vector is because the length of this vector is just 1. Okay, but in this case, we want to find a vector whose length is 12, but pointing in the opposite direction of vector v. So to get that vector, I'm just going to put down, let's put the solution first. So I'm just going to put down the vector w which we want. Okay, then first thing I would do is to get a unit vector pointing in the direction of vector v. To get that, you just have to say vector v divided by its length. Okay, so why is this crucial? Well, in the video, one of our previous videos posted on the playlist, where we had to look at vectors, I think it had to do with multiplication of a vector by a scalar. Okay, you're able to understand that if that is vector v pointing in that direction, as vector v like that, okay, then a vector pointing in the opposite direction of vector v will have the same size as vector v, but the only difference will be that the direction will be opposite. So as you can see, the slope should be the same as that of vector v, but the difference is that it's going to use the opposite and it will have a negative sign. So since our vector w wants to be in the opposite direction of vector v, or is a vector you want to find which is already in the opposite direction of vector v, opposite direction, we should give it a negative sign. And then the length is 12. So given that this vector right here, this ratio, will give us a unit vector. By unit vector, that is to say the length is 1. We just need to multiply it by 12 in order to get a vector whose length is 12. So this right here is the desired vector. So it's the vector in the opposite direction of vector v and with size as 12. Okay, that's really nice. But we've been given vector v as that. So maybe let's just make use of what we've been given. First of all, we want to find out what the length of vector v is so that we can substitute right there, right? Okay, so what's the length of vector v? Okay, so in a video where we talked about length of vectors, we're able to discover that, okay, given any vector, just take the sum of squares of the entries. That is to say, sum of squares of the, can say, orthogonal component of that vectors in the, orthogonal component, that is to say in the ijk direction. Okay, so in that case, we're going to say the square root of the sum of squares of the entries. Okay, so when we square the first entry, we're going to get that's 9 sine squared. Then we add it with the square of this. Let me just put the 9 cosine square of t. And then lastly, we square negative 4, which will just give us 16. So this is what we're able to find out. Maybe let's simplify this a little bit. Notice this is 9 sine squared. And then this is 9 cosine squared. Of course, you know that when you factor out the 9s, you're going to get sine squared plus cosine squared of the same angle. The result is just 1, which will give us 9 times 1. That's 9. Then we add 16 to that. So this should give us square root of 25. And we're going to get the positive result, which is just 5. Okay, length of vector v, which means we can rewrite this vector w as negative 12 times the vector itself without touching it. That is 3 sine theta. Okay, comma 3 cosine theta. Sorry, t, not theta, and then negative 4. Good. We divide that by the length of vector v, which we've discovered as 5. So that's just what I'm going to put down there. Okay, maybe we want to do a little more work on that. Well, what I'd like to do here is to rewrite this thing a little bit using the ijk notation. That is to say, I'm going to put this out as negative 12 times 3 is just 36. All right, so that's negative 36 sine theta over 5 in the I hat direction. Then we have that to be negative 36 cosine theta, cosine t over 5 in the j hat direction. That's unit vector j hat, and then plus 48, that's 4, that is 12 times negative 12 times negative 4 over 5 in the k hat direction. So this right here is our desired vector w, which points in the opposite direction of vector v, and its size is 12. So just follow the process. This is the main thing, then you find out the length, and then you can substitute and then write if you wish. Okay, maybe let's do another example just to maybe master that kind of example. So the second example is similar to the first. So we want to find, okay, we are given vector u, which is this. We want to find a vector, a half-sized vector of u in the direction of u. Okay, so we want to find a vector whose size is half of vector u, and that vector should point in the direction of vector u. It shouldn't be opposite, unlike the first example. All right, so maybe let's call the vector something. Let's say let the vector be, maybe you can just use w. All right, let the vector be w. Okay, so in that case, we will do something similar. This means that w is what? It's a vector which is half the size of vector u. So whatever vector u is, half of its size. That's serious. So half of the size of vector u. So that is vector u. If that is the length of vector u, half of that length will be the length of this new vector. So we should be careful with that. Okay, so this is like the length in the place of 12. In the previous example where I used 12, this is exactly where I'm using half the length of vector u. All right, good. And it should be in the direction of vector u, which means I don't need to negate it. It's not opposite, it's the direction. That's the exact direction. So we are good with the positive value there. Then it should be in the direction of vector u. So to be careful with that, we'll have to say let's multiply it by a unit vector pointing in the direction of vector u. And to get that, we just have to say vector u divided by its length. Good. So this is what we want. Of course, you could easily just cancel these lengths because they are simply numbers, which will give us that w is half of vector u. Okay, so that's simple. So to get a vector which is half of a certain vector pointing in the direction, just divide that vector by 2. What this scalar does is that it shrinks this vector, that is, it splits it into 2, then taking only one part. So it doesn't change the direction of that vector, it only reduces the vector. So if this was the original vector u, then half of it should be somewhere here. So vector w should just be half of that. So it should just be one of those pieces, right? Good, something like that. So that is vector w, given that this is vector u. It points in the direction of vector u, it has half the size. So we don't even need to calculate anything. But I did mean it was to be in the opposite direction of vector. You just need to add a negative here, and we are good to go, right? Okay, that's a good one. In the next video, we're going to deal with product of vectors. And in product, we consider 2 types of product. Okay, I hope you enjoyed the video anyway. Thanks for watching. Please don't forget to subscribe to my channel, and we'll continue from my next video.